Thank you, Martin. A very warm welcome from my side as well. As Martin mentioned, I'm speaking to you from Singapore. It's 11 p.m. here, so I'm especially happy about all the attendees from Asia who are joining me at this late hour. But of course, I would like to say hello as well. Good afternoon to Europe. Good morning to our friends in North America. It's my pleasure today to speak to you about SerDes Channel Design and Characterization. And maybe I'll start with a very simple diagram that explains what a SerDes channel is. I realize many of you know this in and out, but maybe there are some other customers, CST customers, who are joining us that are not too familiar with this term. So a SerDes channel normally consists of a serializer and a deserializer, hence the name SerDes. And between the serializer and the deserializer, we would have a single pair of transmitters and receivers that are connected with a channel. Of course, as you can see quite clearly from this diagram, in this channel, the bits would have to move at a much higher rate in order compared to a parallel transmission of these bits. But they can do so because we need less transmitters and receivers and less space than with a parallel transition, so we can spend a little bit more effort on the transmitters and receivers. So we can do things like clock recovery, we can do things like emphasis and equalization, we have less crosstalk issues, and also less susceptibility to noise because those channels are normally done in a differential way. So for this webinar, I'm going to tell you the story basically of the design of a PCI Express channel. I think there's a typical use case. Let's put us in the shoes of a designer who is designing such a riser card. You would see here the socket where the card goes into the socket. Here you have a CPU or an FPGA, and then you have other interfaces on the card.